Hello everyone. Today I will talk about generative artificial intelligence in chest X-ray interpretation. This study is an expert consensus of the Korean Society of Thoracic Radiology using the Delphi method. Chest X-rays are one of the most common tests in hospitals. They are important, but we face two big problems. First, the number of exams is huge, and second, the number of radiologists is limited. Recently, AI has developed rapidly, and many tools can now draft radiology reports automatically. This is attractive because reports are the key way radiologists communicate with doctors. But current evidence is limited. AI often looks good in text similarity, but real clinical errors can be missed. In Korea, an AI tool for chest X-ray report drafting was recently launched. It is not yet approved by regulators, and accuracy and safety are still uncertain. So, the Korean Society of Thoracic Radiology, or KSTR, started a project. The goal was to make a position statement based on expert opinion. We did not use one standard data set. Instead, each expert collected 60 chest X-rays from their own hospital. 20 thoracic radiologists joined the study. The cases came from 6 settings: screening, inpatient, emergency, intensive care unit, respiratory outpatient, and non-respiratory outpatient. The AI system was research use only, called Kara-CXR, later renamed AI Read CXR. All images were pseudonymized and uploaded to a demo website. This figure shows the example CXR interpretation generated by an AI-based automated report drafting tool. Our survey had 3 domains. First, performance, accuracy, reliability, and error frequency. Second, clinical applicability, use with or without radiologists. Third, radiologist benefit, workflow efficiency, and diagnostic value. We had 12 key Delphi questions scored on a 9-point Likert scale. The survey also included demographic questions and non-Delphi items. We used 2 Delphi rounds. Round 1, experts scored 72 items. Round 2, they rescored after seeing group feedback. Score 1 to 3 meant negative, 4 to 6 meant neutral, and 7 to 9 meant positive. Consensus meant more than 70% in one category. We also checked validity and agreement with statistics. Before the survey, each expert reviewed 60 chest X-rays. They gave feedback on accuracy, hallucinations, and errors. They also recorded scanner type and case details. This ensured everyone was familiar with the AI system. These responses were later considered with Round 1 research. This figure presents the summary of study process. We measured accuracy, hallucination, and error rates in different settings. Accuracy was highest in health screening settings. hallucinations and errors were lowest in the same setting. In ICU and emergency cases, AI performance was weaker. This table presents the responses to multiple choice questions. A majority of respondents emphasized the importance of education and guidelines, particularly those addressing regulatory mechanisms and the disclosure of objective performance information. This table presents the Delphi survey summary. Consensus emerged for 41 of 72 items, 56.9%. Respondents adopted a neutral stance on most questions concerning accuracy and clinical integration. The tool neither impressed nor disappointed decisively. Let me now summarize the study and the position of the KSTR. The aim of our project was to create a position statement on AI-based CXR report drafting. We combined expert survey research with practical feedback from real case reviews. The overall stance of experts was neutral. AI is not useless, but not ready for routine practice. The most positive result was in health screening exams, where accuracy was higher and hallucinations were fewer. However, for routine hospital practice, experts opposed using AI alone. The final KSTR position is clear. AI can be used in health screening, but only with radiologist validation. For wider adoption, the tool must improve, be validated by strong evidence, and be supported with society guidelines and education. In summary, the KSTR supports AI-assisted report drafting only in health screening and only with radiologist validation. Standalone use of AI in daily practice is not recommended. For broader use, we need better performance, more evidence, and society-led education. Thank you for your attention.